Hello everyone, welcome to another video on shell coding on ARM Assembly Linux 32-bit course presented on YouTube. So in this one we are going to talk about the move instructions and all the variants which we can use in ARM assembly. So talking about the move instruction, we all know what it do. It just move the operand into a destination register. An operand can be an immediate value or a register. But what we need to notice is when we use immediate value to store into a register or move into a register, destination register, the maximum value which we can just move as an immediate value in 32-bit mode is 0xFFFF or 65536. If we just store greater value than the 0xFFFF, then an error will be allowed. So this is the limitation in ARM 32-bit assembly, whereas in 16-bit of assembly, this limit is of 256. If you move the immediate value greater than 256 into a destination register, error will be allowed. So at this point, many of you might think, how can we just entirely full a 32-bit register with 32-bit values? Do we need to just add and just full the 32-bit register? So the answer is no. There are certain instructions which ARM provides us, and those are MOVW and MOVT. So what does these instructions do is MOVW stores the lower 4 bit of a destination register and MOVT is used to store upper 4 bits of a register. From the given example, we can see that MOVT is used to fill the upper 4 bits of the R1 and MOVW is used to fill the lower 4 bits of the R1 register. At the end, after just executing these two instructions, the R1 will ultimately store 0x12345678. The upper 4 bits are 1234, lower bits are 5678, which we have described here. So there are certain limitations with MOVW and MOVT instructions is that we cannot use a register as an operand. As we can see in these examples, we are using only immediate value. So this is the only limitation which is having in the MOVW and MOVT instruction. And a fun fact, the MOVW and MOVT instruction can be used in 16-bit mode too. After this, many of you might think like, how can we use 32-bit register, 32-bit register in a 16-bit mode? So there are certain consequences, some distinctions, some concept I can say that makes ARM mode and thumb mode different. The instruction sizes which is executed by ARM mode and thumb mode differentiate, but the usages of register doesn't changes. If you don't get this right now, don't worry. In later videos where I just confess about the ARM mode versus thumb mode, you will get to know this entirely. Talking about the next move instruction is the move negate instruction or MVN instruction. So what does this do is it just performs a NOT operation on the operand and stores that result into a destination register. We can easily see by our example, we are moving 0 to R0 and moving a negate of R0 to R1. So ultimately after this instruction, what the R1 store is the NOT of 0, which is ultimately 1111 of a 32-bit register, or the entire 32-bit register is filled with 1 or negative value we can say. So there are certain limitations with move instructions too, move negate instructions too. We cannot use immediate value to directly do a NOT operation and store it into a destination register. Here we can easily see with move instruction I have used register. I can't use immediate value, it will be allowed an error. So do you still remember the CPSR register which we have just introduced in the previous video? Yes, those NCCV flags, like negative flag, 0 flag, Jazale flag, Indian is bit flag. So there are some instructions which ARM provides us by which we can use the CPSR register to use into the move instruction to perform move operations. At this point, many of you might guess correctly, like we are doing a conditional move because CPSR registers allows us to make choices and we can make choiceable or conditional move operation. So there are certain limitations too with the move conditional instruction is these can be only used in ARM mode, not in thumb mode. So from shell coder's perspective, it is of no use, but from a developer's perspective, it is very useful because it may reduce the instruction size a lot because we have to perform multiple steps to achieve something and we are getting in a single instruction. So what are all move conditional instructions? So these are move CS. What does this mean is if the carry is set, then perform the operand, then perform the move operation where operand will be just moved into a destination register. Likewise, all the conditions are described here. Like CC stands for carry clear, EQ means 0 is equal to 0 flag is set, not equal 0 flag is not set, and the VS or overflow flag is set or VC or overflow flag is clear. So all of these instructions are just conditional move instructions by which these values validate the values of CPSR register and performs the move operation on the operand. So let's create a program where we will just use all of these instructions which we have just visited, like move instruction, move negative, move W and T, all the conditional move instructions, and create a program and try to just showcase you what is happening internally at the debugger level. So let's create a program and debug. So let's move on to our computer screen. So what I have done is created a simple file ARM32 move instructions named move instruction, where I just showcased all the things which we have just used or viewed in the slides using the move instruction, storing the immediate value, storing the maximum limit of immediate value of thumb and arm mode, and using the MOVW and MOVT instructions, and all the things which we had just discussed in the slides is just showcased in the code. You can download the code from the description and try it on your own. So what I am going to do now is going to debug the program in the GDB, where we will use the QEMU ARM utility. If you have not viewed the initial setup video or fourth video of this playlist, just go check it out. From there you can just just get to know how we can download QEMU ARM utility to execute ARM instructions on non-ARM computers. So what I am going to do is link this file with an external library, custom library, which I am defining ARM Linux GNU EABHF. By the tag G, I am getting a debugger server on 1234 of the process ARM32 move instructions. After entering this, in the debugger, I have just used file command to load the symbols of the file. And now I will just connect to the debugger server by target remote localhost 1234. At this point, the debugger server is just instantiated in the second terminal. So what we can do is just use SI to step instruction. So at this point, the R0 will store 10 value, we all know, by just viewing the value R0, it is 0xa or 10. After certain instructions like moving R1 with R0, so R1 will store 10, moving R2 with R0, so all these registers will store value 10. So if I just view the register value R1 and R2, those are all 10. We can just easily notice here. The next instruction is the move with 255 0xFF. So what this instruction will do is store 0xFF into the R1 register. It will not create any kind of error if we just store greater value than this, like we are doing in the next instruction, because we are in ARM mode, not in thumb mode. So in thumb mode, this is the maximum limit of immediate value we can store into a register. So after stepping certain instructions until the MOVW instruction, so what we have done is now we are on the point of MOVW instruction and MOVT instruction. What we are storing is 0x5678 and 1234 into the R0 register. After this, before stepping ahead, we will just look at the value of R0, which is 0. After stepping 2 instructions ahead, the value of R0 will be 1, 2, 3, 4, 5, 6, 7, 8. Stepping 1 instruction ahead, if we just move negate of the R1 register into the R2, what will happen is R2. It will be FFFF and 000, because the lower 4 bits of the R1 register is FFFF and the upper 4 bits of the R1 register is 0000. After using a move negate instruction, the upper 4 bits will be set to 1 and lower 4 bits will be set to all 0. Basically negate all 0. Now on we can easily see the conditional move instructions which you are now executing a lot. If the carry flag is set, which is just we can see not taken, the carry flag is not 10. So the R0 will not store value 10. After stepping one instruction ahead, we can easily see R0 value which is not changed because carry flag was not set. But after this instruction move CC, because carry is clear, the debugger output we can see taken. So after stepping one instruction ahead, we can view the value of R0 which is 14, which in decimal is 20. So next instruction is move EQ, not taken because 0 flag is not set, so it will not move. Next instruction is not equal to, means 0 flag is 0. So what it will do is it will store the value into the R1 register. From the debugger output we can easily just identify what all the instructions are actually doing. Overflow is not set, overflow is clear, then it is taken. The operand is a positive value, then it is taken. Operand is a greater value than the data stored in register 4. We can see that R4 is 0. The number 10 is greater than the R4 register's value. So therefore the operation will be conducted, and it will not conduct because the R4 register is less than the 20. So it is not taken ultimately. From these instructions we can easily identify what all these instructions are actually doing. I will not go in depth actually in these instructions. You can just debug on your own, view the entire playlist, know how to just create your debugger session which we have just created here, and just debug yourself, learn yourself. Nobody is going to help you out in the real world. You have to understand it yourself, like I am doing so, although I am not a very good assembly level developer or an expert developer. Stepping instruction, we can easily see this is a simple exit syscall, just gracefully exiting the program, and that's all for this process. So that's all for this video. We have just used all the move instructions and the variants which we are going to encounter in ARM assembly and thumb mode assembly, we can just say. So that's all for this video. If you have any question related to this video, you can just simply ask in the comment section. From there you can do and ask anything you want, and the query will be resolved within an hour or two. You can download the code used in this video from the description below. Also the slides used in this video from the description below. From there, from those slides, you can just locate to my Twitter and GitHub handles, and you can follow as well. That's all for this video. Meet you in the next one.